So we see here in example 1, Alex makes $61,992 per year and pays about 25% of his gross monthly income in federal and state taxes. So let's just go ahead and figure out what taxes are here. Taxes, he says 25%. And he makes 61,992. And so to calculate that, we're going to take 25%, which really becomes 25 over 100, and which is also the same as saying 0.25. So if I say 0.25 times 61,992, then I can calculate how much his tax liability is going to be. So let's go ahead and calculate that. That's 0.25 times 61,992. And that comes out to 15,498. Now this is based on an annual income of $61,992. So 15,498 per year goes to taxes. Let's average that out and find out how much that is on a monthly basis. So we're going to have to take 15,498 and divide that by 12. So when we do that, we get on a monthly basis that Alex is paying $1,291.50. We've also talked about how the recommended rule of the budget is that 25% to 30% of a gross income is for rent. Then a good estimate to use is 28%. So if we calculate 28% now of our original, so we went 0.28, and we're going straight back to 61,992, and then let's just go ahead and divide that by 12 right away, and we end up with a monthly of $1,446.48. So that's really saying that he can afford on a monthly basis to pay $1,446.48 monthly, and we'll say rent. So now we're talking about on a monthly basis, how much does he have as far as free spending money? Well, we're going to take 61,992 and we're going to divide that by 12, because this is what he's going to make on a monthly basis, and he makes $5,166 a month. So on a monthly basis, then we can calculate what his spending money is going to look like. It's $5,166 minus what he spends on tax, $1,291.50, plus what he spends on monthly rent, $1,446.48. Let's see what he ends up with on a monthly basis to spend on groceries and other things. 1,291.5 plus 1,446.48, and then subtract that from 5166, and he has $2,428.02 a month. And that's not bad. Okay, in example 2 here, we see that Rufus and Maria have both been offered new jobs in a different city, and a real estate broker sent them a listing of apartments in their desired location showing the square footage in each apartment. Use linear regression analysis to determine if there is a correlation between the square footage of rental property and the amount charged for the monthly rent. What is the linear regression equation? Interpret the correlation coefficient. So if you look down below, and you remember we did learn about how to do an LRL, a linear regression line, and There's ways of doing that on the TI-84 Plus calculator, and then there's also ways of doing that with the with Desmos, the online graphing calculator, and we will have talked about that by now. If we do that, then we get a picture that looks like that scatter plot with the best line of fit right there, and we also get this lin-reg information where a is equal to ax plus b, where the value for little a is 0.906157342 and little b is equal to 403.0870898. And r squared, which helps us calculate our correlation coefficient, and you remember a correlation coefficient, the closer it is to either 1 or -1, tells you that it's got a strong relation to truly representing the data. And this is at 0.96. So that's a strong relationship. And so if you look at that line of regression right here, you see that the points of real data are actually really close to that line, telling us that it's a very good predictor of that. And so that's how much they would be expected to rent these apartments for. So based on this example, what would be a good estimate for the amount of monthly rent charged for an 880 square foot apartment? Well, let's go ahead and figure that out. See, what they're saying is, what if X was equal to 880 square feet? And so all we have to do now is take our linear regression model, which is y equals 0.91 times 880 plus 403.09. And if we do that, I get 1,203.9. We'll just call that 90. If we look at the table here, then we can see that between 872 square feet and 903 square feet, we have costs of about 1,205 to 1,245. So actually, the number that we came up with is a more desirable number because it's actually lower than what they were talking about, because we're at 1,203.9. Now in example 3, we've been talking about what does it cost initially to actually start renting something. Well, we've got a few things that kind of add up here. Starting with, there's a $200 application deposit for a 1,150 square foot apartment that we talked about for Rufus and Maria in example 2. Now, in example 2, we also knew that from the table a 1,150 square foot apartment would cost on a monthly basis $1,595 per month. So we have to keep that in mind. Now, the application deposit is $200. They are also asking for a credit report fee, and that's an expense of $25. So we got $225, and we have to pay a security deposit, which is based on monthly rent. So they're going to say 1 month's rent, and that's $1,595. And then there's a final month's rent, just to guarantee that you're not going to just run out when you decide to leave the apartment. And so there's another $1,595. Now, there's also a brokerage fee calculated because, and it's based on an annual, so you have to take that 1,595 multiply by 12, and it's a 10% fee of the annual cost. So you're going to take 0.1 and you're going to multiply it by 1,595 times 12, and we get $1,914. And then there's the first month's rent, which is $1,595. So the total expenses, as we're planning on moving into this new rental, totals out to $6,924. And that's what Rufus and Maria should expect to pay before moving into their apartment. So as we check for understanding here, we've got now Larry, and he's renting an apartment that will cost R dollars per month. So R is the monthly fee. And he must pay a $100 application fee plus the $25 credit report fee, and his security deposit is going to be 2 months rent. So he has to pay 2R for what he's going to do for security. And then he must also pay the last month's rent. So there's another R to add to the stack and upon signing the lease. Now his broker charges 5%. So this is going to be 0.05 times 12R because that's how much he's going to be paying on an annual basis. And so here we're going to express the terms, and we can add all these numbers together. We add up with 125 plus 3R plus 1/10 of a half. So we've got 0.6R. So that adds up to $125 plus 3.6R. So here we have an example 4. Jay is moving from an apartment in Miami to one in Orlando. If Jay moves on a weekday, he'll need more movers time to pack, load, and unpack because his friends will not be available to him. And so if he moves on a weekend, though, he can get his friends to help, cutting down on the number of hours he will need to hire movers. Move Out is a moving company that supplies movers, trucks, and moving equipment, and they have given him the following moving estimates. On a weekday move, there's 6 hours of loading and unloading, 5 hours of packing and unpacking for a total cost of $720. If he does the weekend move and has his friends helping, now he thinks it's going to take 4 hours of loading and unloading and 2 hours of packing and unpacking, and it'll be a total cost of $400. To set something like this up, you need to kind of set up your variables, and so we're going to let X represent the hours of loading and unloading, and we're going to let Y represent the hours of packing and unpacking. And so if you look at the weekday move, this is how it looks. You end up with 6 times X plus 5 times Y, and since that's the X and Y are costs for the loading, unloading, and packing and unpacking respectively, that's the hours that they're working on them, and that comes out to $720 of total cost. Now, if we did the weekend move, now we're talking about 4 times X plus 2 times Y, and that only costs $400. Move Out charges that set hourly moving team rate for loading and unloading and a different set hourly team rate for packing and unpacking. Why don't we try and now determine the Move Out hourly rates? Well, so we've got the rates for X and the rates for Y, and if you recognize this is an elimination problem. So what we're going to do then is we're going to take 2 times the first system, and we're going to go negative 3 times the other system. And so if I do that, I get 12x plus 10y. 2 times 720 would be 1,440. And negative 3x times that bottom line ends up being negative 12x. And maybe you're starting to see it. Minus 6y equals negative 1,200. Look at what we get. We get an elimination. The x's go away. and I get 10y minus 6y is 4y, and I get 1440 minus 1200, that just gives me 240. So if I divide by 4 now, I end up with the y cost, which is the hours of packing and unpacking. That turns out to be $60 an hour. So $60 an hour. And so now all we have to do is turn to one of the originals, like 6x plus 5 times 60, and equals 720. 5 times 60, that's 300. So now we look like this. 6x plus 300 equals 720. So if I subtract 300, now I have 420, and I've got 6x is equal to 420. So divide by 6, x is $70. So I have $70 per hour for loading and unloading, and $60 an hour for packing and unpacking. Okay, here's another moving example in example 5, where we have Samantha, who is moving from Madison, Wisconsin to La Crosse, Wisconsin. She will do all of the packing and unpacking by herself with her brother. The moving company quoted a price of $1,250 for 8 hours of loading and unloading and driving 130 miles. The company quoted the same price if the truck drives an extra 30 miles to pick up Samantha's brother, and Samantha figures that with her brother's help, she only needs to hire the movers for 6 hours. So the question is now, how much does the company charge per hour for the loading and unloading? And how much do they charge per mile for the driving? So if we let X now represent the hourly cost for loading and unloading the truck, and Y represent the per mile cost for renting the truck, we're looking at a situation where without her brother, we're talking about 8 hours of loading and unloading. So that's going to be 8 times X plus, and we're talking about 130 miles of driving. So that's going to be Y miles of driving. Y is the charge for per mile. And then we've got 6 hours now, if brother helps, of loading and unloading. And so that's going to be 6x plus, and then there's 160 miles because we got to drive an extra 30 miles to pick up brother. And that's going to cost the same amount, $1,250. So each of these costs $1,250. Now if we take a look at this, we see 8 and 6 and know that they are both multiples of 24. So 8 times 3, so we're going to multiply this guy by 3, and we're going to multiply this one by -4. And watch what we can do. We got 8 times 3 is 24x, and 130 times 3 is 390. Y, 1,250 times 3 is 3,750. And then -4 times 6 is -24x, plus 4 times 160 is 640. Y. And 4 times 1,250 is 5,000. So when we subtract, we get 24x minus 24x, and we got 640 minus 390, and we end up with a -250. and that's going to be negative 1,250. So we divide by negative 250. And negative over negative gives me positive, and 250 goes into 1,250 5 times. So it looks like they're charging $5 per mile. Y is $5 per mile, and we can take that and go back on either one of those. So let's go ahead and do the second one again. So we're going to do 6x plus 160y is equal to 1250. But that's not y, that's equal to 5. So we're going to multiply that by 5. So that ends up being $800. And when I subtract 800, I end up with 450. And so I've got 6x is equal to 450. I'm dividing by 6. And I actually know that those are top and bottoms divisible by 3. That ends up being 150 over 2, and half of 150 means that x is equal to $75 per hour. So $75 per hour for loading and unloading is those costs.